Hi guys, want to start LunchBox plugin. So let's go. First of all, for having the plugins installed, it will be given a separate video tutorial by which you can learn how to download them, the latest versions, and also how you can install them on your devices. But right now, here as you can see, we got the plugin of LunchBox added to the software, which is made up of multiple tabs. That at the first part, we're going to talk about Math tab, as you can see, that provides us with some prepared geometries. We will talk about some of the tools and commands, and I leave others for you. Following that, we want to talk about the Structure tab, like space track structure and two-dimensional structure. And then it's time to talk about one of the most practical items, which is panels, that I hope you will enjoy this session. So as I told you before, in the Math tab, here we are given some prepared geometries. Check it out. You can just open the Math tab and then select the intended geometry, so then we can have it in the scene in the perspective view. And then if I bake it, check it out. Let us check it out in the shaded viewport, or rendered viewport actually, like this way. We delete it. And let's talk about the inputs that we should associate to this. For example, U and V divisions or R parameter. For instance, I add a number slider, I give it to R. Check this out. I increase it by this way, which is the number of the arcs in the geometry, as you can see, or the number of the arcs used in the geometry, and the scale and domain 1 and 2. For instance, I add a panel, I specify the domain 0 to P. Watch this. This is the result. And stuff like that. And let me show you others like this one. Mobius or plane surface or torus surface, and other items like this, the platonic solid. And in a Structure tab, we got access to the 2D trusses and 1D and 2D structures. For example, the first one is two-dimensional truss that requires two curves for the inputs. For example, by using interpolate curve, I draw two curves in the Rhino scene. Then I want to use curve components. I want to set the curves to Grasshopper by this way. And then in LunchBox, I'm gonna use 2D truss. I give curve A and B. Watch this. Here we got the two-dimensional truss. Following that, we select the control points and then move them. Watch this. As you can see, we created a 2D truss in a very simple process, so we can control the number of divisions, like 11. Then we can increase it or decrease it. And in then truss toggle, I hold the cursor, you can see toggle between truss web configurations. If we type 0, 2 direction web, 1 single direction web, and if we type 2, it reverses single direction web. Let's check it out. I add the number slider between 0 to 1, and then at the top view, to observe the object better. 0, check it out. And if I set 1, watch this. As you can see, check out the direction, and then 2, which reverses the direction, or it reverses the previous mode. And We name these straight lines vertical lines and the slanted ones are brace lines. So to do this, we can use pipe and we give the brace lines to curve of pipe to convert them into pipes, and as you can see, the brace lines are the slanted lines in the truss, and then the primary lines, which are the two main lines, and you can use the structure nodes as the base of the spheres. Watch this, which is the connection point of the brace and vertical lines with primary lines. So guys, this was the first command of structure for 2D truss, and the next one is braced create two-dimensional structure. You can create a two-direction braced grid structure on a surface. Let's check it out. Here we should specify a surface and U and V divisions, then we will have the braced lines or braced grid. I'm gonna use the previous curves. I search for extrude. I give the curves to extrude the curve along y-axis. Watch this, let me open some space, and then the extrusion distance for the surface by using the number slider. Check it out, I open some space. Following that, I give the surface to the input surface of braced grids. Check this out, here we got the braced grids. Then we can specify U and V divisions by which you can control the number of the divisions along U and V directions. Check it out by this way. And the next one is grid structure. Here you can create a simple grid structure on a surface. We give the surface that we got the grids on the surface. And the next one, braced grid 1D structure. The previous one was 2D. Here we got rectangular grids with one brace line. The next one is diagrid structure. As usual, we give the surface. As you can see, we got some diamonds on the surface instead of rectangles, so we call it diagrid or hexagonal structures. Watch this. The divisions are in some hexagonal structures or polygons. However, here we got adjust shape, which is just shape of the hexagon. We specify value between 1 to 0. Then adjust the shape of the hexagon. Check it out. If you specify 0, we will have the diamonds. And then if I set 0.3, we will have the hexagons. And as we get close to 1, we will have triangles, as you can see by this way. And finally, space truss structure 2, that you can create a space truss structure using two driver surfaces, in one driver surface or using two driver surfaces. Let us try it with one driving surface. We give the surface, check it out, and then by specifying U and V divisions counts, we can have the space truss structure 1 and then truss depth. For example, 1.25. We can specify the depth of the truss. Check it out. And if you wanted to flip the direction, you can right click on the truss depth and then type minus or negative, minus x or negative x to flip the direction. And the last one is space truss structure 2. This time we're gonna use two driving surfaces. Check it out, surface A and B, move. First of all, we create another surface to associate them to surfaces of A and B. Following that, we can have the space truss structure between these two surfaces that we can control the U and V divisions just like before. Well done. Wait for a second, please. Very well. Let us continue. We select these and then delete them. Then the surface. I want to explain the panels upon the surface. For example, however, I will talk about Diamond Plus, which creates diamond panels on the closed surface. I will share the file later with you, but let us talk about Diamond Panel. We give the surface, watch this, and we can convert it to diamond panels. I mean the diamond panels and the triangle panels, that they are separated in the outputs and you can select them independently. And if you wanted to export these panels for yourself, you can use surface and then give the diamond panels. Check it out. You get only the diamonds, not the triangles. Check it out. And if you wanted to extract the edges, you can use curve. For example, we can give the diamond panels to the curve, and then we will have this surface edges, because if we associate a surface to a curve, we can extract the surface edges, as you can see in the screen. And the next panel here is hexagon cells. Here, as you can see, we can create our panels in some surfaces except hexagon panel, since hexagon panel are drawn with some curves, not some panels actually, or surfaces. We can specify U and V divisions and the 3 parameters that I have talked about it before, a value between 0 to 1, like this way. And the next one is quad panel, that creates quadrangular panels on the surface. Watch this. We give the surface. And random quad panels, which creates randomly staggered quad panels on a surface. Check it out. After giving the surface, we specify U and V divisions and increase them. Watch this. We will have such a result like this. And about the others, like skewed actually. Let us try this. We give the surface. As usual, we got the U and V divisions and staggered quad panels. We can give the surface U and V divisions, which is similar in all of them. Check it out. Triangular panels, like this way. We're almost done with the panels here. For example, quad panel, surface, and then I'm gonna use panel frame. We can find it in generate. We can convert them to some frames. Check it out. We give the panels. Watch this. We got them in frames. And then by using custom preview, we can assign a different color to the frames to show them distinguished. And we add the color swatch to the material, and then assigning a new color for the material like cyan or blue. Watch this. This is the result. So guys, in general, we got familiar with plugin LunchBox. LunchBox plugin, I'm sorry. Structure, panels, and math. For example, we can use these basic geometries like an upper surface. Let me select these and delete some of them. And then I'm gonna use this object, and also using the panels for dividing the panels like diamonds. Watch this. 16 for U and 60 or 80 for V. And then I'm gonna use the panel frames to extract the panels, return of these. Following that, this is the result. We bake the panel frames okay. Then let's check it out at the rendered viewport in Rhino. It is very great that you can create such a geometry in just a few seconds, and then from display, use application settings. And then I wanna display the surface edges by this way. I mean, by using just these commands in LunchBox, you can create such a geometry in a few seconds by just these plain commands, which shows the power of the LunchBox. We turn off these and delete these to clear the canvas. Then I want to give you another example using LunchBox plugin. For instance, I'm gonna use here in primitive, I pick the circle by this way, and then I wanna specify the radius like 6.5 to draw the first circle. Then I want to move the circle, watch this, along z-axis, and then the distance, which is 12 meters. I move it more. Well done. We select these, we make a copy from move and factor, and yeah, and we move it in 27 meters. Watch this. And then I want to scale the middle circle. We give the geometry to a scale, and then we calculate the centroid to scale the circle from the center, and then the scale factor 1.5, the first, second, and the third circles. And then we give the circles to love to create such a tower or cylinder or something, or the surface. As you can see, we can select the circles, turn them off, and control the radius of the circle or the continuity like this. However, we could have scaled the top part of the surface. And then I want to use LunchBox commands like hexagon cells. We give the surface to create multiple hexagons in the surface. We specify, I want to increase the U and V division 12 and, for example, 14 by this way. Then we want to use scale command. We give the hexagon cells and their centers as the base point. Then let us specify the scale factor that I want to associate a panel to scale factor, defining 3 values n. We add the panel 1, minus 0.65 and 0.25. Right click, multi-line data. Don't forget this, guys. When you are using multiple values or data in the panel, don't forget to click on multi-line data. Let's check out the result. This is not what we expected. I mean, one is assigned for the first ones, the next one 0.65, and others are scaled at 0.25. But how did it go? Here, as you can see, we got 98 hexagon cells and also 98 centers and 3 scale factors. Following that, each of these hexagon cells that I wanted to display them in the canvas by using these curves, and I want to show the centers by these points or X, and also the scale factors. So just like the shortest distance, which is the behavior by default, each of the items are connecting to each other, and then according to the longest distance, since one of these streams has run dry, the items of the other streams are connecting to the last item. So here I want to consider each of these scale factors as independent groups, three separate groups that each one of these groups are going to have interactions with other groups. I mean, I want to create connections between all of these groups, these three groups of scale factors. But how? Let me show you better. For example, here we got the hexagon cells and also the center. Then I want to scale them with the scale factor 1. I mean, I want to scale the hexagon cells 3 times because we got 3 scale factors. One with 1, one time with 1, one time with 0.65, and one time with the 1.25. And for the other hexagon cells, but for doing this, we should search for graph tree. And then we give the list to the tree in order to create 3 separate lists. Check it out. This is the final result. We can turn off the preview of hexagon cells. And right now we got the hexagons like this way at the mentioned process. For example, we got these data or these items in a separate list, and these are the hexagon cells. Suppose that here I draw several hexagons or polygons to show the hexagon cells as the first group of data, that each of these hexagons or polygons got their centroids or centers. Then I want to display the points as the centers. Following that, 3 values for the 3 scale factor like this way. Watch this. But before using graph tree, this was the default behavior between the group of items, the polygon, the center, and the scale factor 0.65, and the next one 0.25, and the other ones are scaled at 0.25 scale factor. Watch this. Based on the longest list behavior. Then at the next stage, after using graph tree, that we have considered each of these scale factors as separated groups or independent groups. Then each of these items are considered with all of these scale factors. Watch this. First, second, third, and so on to the end of the list. And after the stream runs dry, it starts assigning the next scale factor, which is 0.65. Check this out. And when the stream runs dry, it will be started again for the third group of scale factor. So by using graph tree, we managed to scale each of the hexagon cells at 3 scale factors 3 times. Then in the continuation, I want to move these hexagon cells inside and outside, but here we do not have any specified axis or direction or vector. I mean, we can't move the hexagon cells along X or Z axis. So what should we do? Here, let me exemplify a case, and then we move the process forward. For example, here I want to draw a planar surface, deformable surface like this. We show the control points, and we can increase the number of control points like soft edit surface. Watch this. U distance 20 and also V distance. Check it out. I edit the surface like this way. And then I'm gonna use a surface parameter to set the surface in Grasshopper. I hide the surface in Rhino, and then in LunchBox panel I pick hexagon cells and I give the surface to the hexagon cells. Then in the continuation, I want to move each of these hexagon cells perpendicular to the surface toward inside and outside. And to do this, we got two tasks. The first one is using the command of surface closest point to find the closest point on a surface. We add the command, then we give the surface and also the centers of the hexagon cells. And here you may question that we had the points on the surface correctly. But right now, in order to find the position of the points according to the U and V directions, we can use surface closest point. So, by using surface closest point, we gave the centers of the points and also the surface, and we are given the point and the UV points, as you can see. Then, by using evaluate surface, we give the surface, the main object, and also the UV points. Check this out in the scene. Right now we got planes at each of the centers, and also we got the normals or the normal directions of each of the planes. So we search for move and we give the hexagon cells, then we specify the normal or the direction. But let me multiple the normal in B, check it out, and then the number slider for B for the distance that we want to move these hexagons. Check this out like this way. So let me turn off the preview of these like this way, and then I want to work on the top or on the surface. First of all, as I told you before, we should search for surface closest point, and then we give the centers to the point and then the surface from loft. And I should search for evaluate surface. Again, we give the surface and UV points to point of evaluate surface. Right now we got the planes which are matched with the points, as you can see, or the frames. And I want to display the scales, the scaled geometries by Prom Viewer. Here, as you can see, we got 3 branches and 98 items at each of the branches. I search for move, I add it, and then I give the geometry of the move. Then for the motion, I should multiply normal into a specified value. Multiplication, we give it to A, normal to A, and then we multiply it in B, give the result to motion. Then for B, we can use gym pool, since I'm gonna consider 3 variable values at the specified range from -1 to -3 to 3. Check it out. Let me specify these 3 values in gym pool. As you can see, we can move them toward inside and outside. Make copy from Prom Viewer. Here, as you can see, we got 98 items in the branch. And here, if I click on graph to graph all data in this parameter, then we will have 98 separate or single items or branches. But this is not practical for us. We're gonna consider the values in gym pool as a group. Graph tree, we give the values of gym pool to graph tree. Since I want to create 3 single groups which are independent to each other, we turn off the preview of these to show you the results. Let us move on. And we can turn off the surface as well. And as you can see, we got 3 branches and 98 items at each. A new Prom Viewer, 98 items at each of the branches. And then flip matrix. We give the data, and as you can see, we got 98 branches with 3 items. Loft to create the surface. And in options, we can open loft options. I set it to straight style. Check it out, can make changes. And we display the result like this way. Very well. Finally, we search for custom preview to assign the colors or modifying the colors of the objects, and I want to assign blue. And finally, we bake it to observe it in Rhino at the rendered viewport by this way. And here we can control the object in multiple stages. Firstly, here we can modify or edit the object in radius of the circle in top and bottom. Watch this. I mean, in general, we can scale the object. Watch this. Or controlling the height and scaling controlling the radius of the middle circle or middle part of the object, and number of divisions in U and V directions, scale factor 2.5, and for the radius 4.5, and then for the motion of the move, check it out. And then we got the scale factors in the panel and also the movements, as you can see. I want to talk about the track point and also point attractor and curve attractor. So I have added bifocals and I have arranged the two windows of Grasshopper and Rhino next to each other like this way. Then let us start. As I told you before in the previous part, that we measure the distances between the attractor, the point attractor, and the other point, and then we consider the distances as the parameter of controlling the movements or the radius or the angle of the rotation or the scale factor and so on. I mean, we moved, scaled, and rotated the objects based on the distances. And at this part, I want to use interpolate curve like this way. I draw a curve. Following that, by curve, I set the curve into Grasshopper, and then I search for extrude along z-axis to convert the curve into a surface unit Z, and then let's specify the factor like 32 for the height or extrusion distance. Watch this, we move them like this way, and I want to create some rectangular panels on the surface. So to do this, I'm going to use by the plugin of, LunchBox plugin. And then from Panels tab, I choose Quad Panels. Then I give the extrusion to the surface of the quad panels, and then in U and V divisions, we can specify the values of U and the divisions of points along U and V directions. For example, I put 2 number sliders, and then we can control the number of the panels. And then by using panel frame, we give the panels, and then we should specify scale factor to scale the panel frames. But this time we wanna specify the scale factor by using the point attractor. I wanna consider a point on the surface and consider it as the point attractor to specify the scale factor. The panels which are close to the attractor point or point attractor are going to be scaled less than the panels which are far from the point. So to do this, at first we should create a point on the surface. Let's check it out. To do this, to create a point at the surface or on the surface, at first we should give the U and V directions. So we got a tool which is evaluate surface to evaluate an expression with a flexible number of variables. Firstly, we give the surface like this way, and then by specifying the directions of U and V, we can have the point. I select these to hide their previews to explain the evaluate surface command. Firstly, I have given the surface the evaluate surface, and then for point, I should specify two numbers. Here we can search for a panel, 15 and 20, like this way. As you can see, I have specified the point and the surface. For example, U direction or the horizontal line 20, and for the V direction or the vertical line 15. These are the coordinates. And the another method that I can use is adding two number sliders and using construct point command. Check it out, construct point. We give the point. Following that, we should specify the X and Y coordinates by number slider. Watch this. Let me hide the point itself, and then we can move the points by these number sliders. And if I increase the value of Y, it will be placed out of the surface. So it is clear that this is not a good idea to use these number sliders, since we don't have the start and end of the surface, the start and end points actually. For example, I move the points like this. Right now, the point is placed at the end of the surface. Then I want to increase the extrusion distance. As you can see, the point is fixed. So this is not my chosen method, because the approach that I want to use for evaluate surface is to right click on surface, and then I click on reparametrize. Then we consider the U and V directions and match them with the range between 0 to 1. I mean, the U and V directions are parametrized, and we can specify the position of the points by giving a value between 0 and 1. In fact, we are remapping the directions of U and V, and the remapped values is a range between 0 to 1. Or in other words, both directions are reparametrized. Then we can search for MD slider and create the point attractor on the surface. So from now on, if you wanted to create a point on a surface, one or multiple points, first of all we add evaluate surface, and then we right click on surface to reparametrize it. I mean, we remap it to the range between 0 to 1. Following that, this enables us to use MD slider for creating the points on the surface. MD slider supports the range between 0 to 1. We give it to point. Watch this, and then we can control the position of the point by using MD slider by this way. And if you wanted multiple points, you can make copies from this slider, and by holding down Shift, you can define new points on the surface. And let me turn on the frames and panels. Check it out. Here we got 2 points, and by using these 2 point attractors, we're going to specify the scale factor of the panels. And let's search for closest point. Find the closest point in a point collection. Note that here we got closest points as well, that we do not use this. But I will talk about these in the following examples. But for now, let us use closest point. We give the points and also the cloud. Here we do not have any point, so by using area, we can find the centroids of the geometries like this way. After obtaining the centroids, we give them to the point, and also the 2 points, the point attractors, to the cloud. Here, as you can see, we got some distances, and by using remap numbers, first of all, give the distances to value and the source that we search for bounds. Check it out. We give the distance to numbers, and then we give the domain to source like this way. And then by using graph mapper, we give the mapped values, and then we should remap the values once more. And here we can use remap number. I mean, here we can skip the remap at this part because we have already reparameterized the directions and the values are between 0 to 1. So we give the graph mapper to scale factor, and then we set the graph types like Bezier graph type, and the specified value should not be 0, and then we scale the frames like this way. Watch this. And here, in order to display them better, I search for custom preview. I give the geometry, then I make a copy. I want to show the panel frames in the specified color. I search for color swatch to set a color for it. For example, like this. I give it to material, check it out, and then I turn off panel frame. Watch this, and I show the point attractors in the scene, and then if I move the attractor points on the surface, we are controlling the scale factors of the panels. And also we can use the graph mapper, watch this, to modify the panels. So guys, we managed to use the point attractors in the surfaces too. Let me change the graph type like sign, or check it out. By this way, I move the point since it should not be 0. Check it out. We are changing the scale factor, and then even we can increase the number of panels 20 and 20. Watch this. Or we can make a copy from the slider to add one more point attractor or remove one of them like this way. Watch this. This is the sign graph type that you can create such a geometry in a simple process. I turn the preview of these off, and then I'm going to use one of the LunchBox tools like Kalen Surface to work on another example. This time I want to use the triangle panels. Watch this. And we give the surface, then for the U and V divisions 24 and 24. Then let us check it out. Then we can modify the numbers, or 60 in 30. Check it out. And then by using panel frame, we can create the geometry and move the example forward like this way. And then here we can decrease the values of U and V divisions, since as we increase the value, the size of the document file increases too. I set 12 and 6 for the U and V divisions, and the geometry does not matter right now, since later we can change them, change the values of U and V divisions, then evaluate surface and reparameterize, and then by using MD slider, we give the point to create one or more or multiple points on the surface, and then we can place them wherever we want. And then by using area to find the centroids of each of the panels, and then closest point, we search for CP, and then we have closest point. We give the centroids and then the point of evaluate surface, and then by using remap number that I explained it before, and then we search for bounds. We give the number and then we give the domain to source like this. As you can see, distance is connected to value, and we have added bounds for specifying the source or for specifying the domain. And then by using graph mapper, we give the mapped values to graph mapper, check it out, and then Bezier graph type, we move the point since 0 is accepted here. Scale factor, we can turn the preview off and then observe the results. Then it's time to modify U and V divisions. So to do this, instead of modifying these by the slider, we can press down a scroll button and then click on Disable Solver to disable the global Grasshopper solver. By this way, we are locking the project, in fact. Following that, we can make the modifications, and the changes are not being updated in the scene, as you can see, or they are not applied on the objects. And even we can make a copy from the slider to add one more pointer tractor. All in all, after making the modifications, and when we were done, we click on Enable Solver. Following that, all of the changes will be applied on the object at once, not in multiple stages. So this would accelerate the speed of the process. Enable Solver. Then we should wait for a second, and then we will have the new geometry with the applied changes. Check this out. As you can see, and following that, we can use custom preview for assigning the colors to the object. We make a copy from them. We give the panel frames to geometry. Check it out. We turn them off and turn these on, and then we're going to bake them. Check this out, like this. Watch this. Then at the rendered viewport in Rhino, we can check them out, and in the continuation I open a new file in Grasshopper to display the baked objects only. Check it out, like this way. So guys, here we're going to start the next practice. Let's check it out. So firstly, we're going to create these surfaces and then the panels. At the first step, we're going to create these panels, and then at the next one, we're going to control the height of the panels by using one or multiple pointer tractors in order to move the panels. As I have mentioned before, we're gonna control the movement of the panels based on the position of the pointer tractors. And right now, as you can see in the photo, the edges are moved toward outside, and we're going to move them based on the pointer tractors. Let's check it out. So first of all, I pick the interpolate curve, and then I draw this, and then my extrude curve, I convert it to a surface like this way, and then I set the surface in Grasshopper. We don't need the curve and the surface. I select them and I hide them by using Ctrl and H. Let's take a look on the picture. Here, as you can see, we got some triangular panels. I want to keep the photo right here, so whenever it was required, we can take a look on it. Here in LunchBox plugin, I open the panels drop down list to open the triangular panels, just like a photo. As you can see, we can use triangle panels B to create triangular panels on a surface. I give the surface to the triangle panels B. Check it out. And here, watch the result. Here in the continuation, we should rotate the surface. I should move the triangles in a way that to have them vertically, not like this. Check it out, based on the photo. So here, the first method is to select the surface, and then by using direction command, dir, I select the surface. Then I should select objects for direction display. I click on swap UV to swap the U and V directions and the specified surface. And the another approach for modifying the directions was using reverse surface direction to reverse the UV direction of a surface. So we got these two approaches for reversing or swapping the U and V directions or flipping them. By this time I've used Rhino or direction command. Let me increase the number of the panels. make a copy from number slider to U and V division, and here we got the panels. But as here we got too many triangles and panels, we can minimize the number of U and V divisions just for example and practice, and later we can increase the number of them since it would be difficult to process the results for the device. So guys, let us continue. We open the photo to take a look on them. Here as you can see, every other panels are selected and every other panels are moved, not all of them. So here we got a selection pattern that we're gonna use dispatch. First of all, we give the list of panels and then we should define the dispatch pattern for defining the pattern of selection. I give list A to surface and I can turn off the preview of the surface. Watch this. List A and also list B. Watch this. Here as you can see we need list B, not list A, based on the dispatch pattern. As you can see, the triangles are displayed in green like this way, and after using the dispatch pattern for selecting the triangles, we should select the edges of the triangles and then moving them. So to do this, we first of all search for a curve to extract them by giving the surface the curve, and then by using explode we give the curves to explode the surface edges. Check out the result. Right now we got the vertices and the edges. Following that, I'm going to select the vertices. As you can see, the vertices of each of the triangles, but I need only the top vertex, so list item. Then I want to extract the vertices, not the segments, so we give the vertices to list item, and then let us define the index between 0 and 2. Check it out. We don't need item 0, but about item 1 and 2. Item 1 is what we need. As you can see, they are displayed in green. So up to now I have selected these vertices, and then at the next step is to move the vertices forward. So I give the items the geometry of move, and then we should specify the motion along y-axis, and then for the distance of move like 0.25 for moving them. Check it out. Here as you can see, the direction should be flipped, so I right click on expression and then I add -x to flip the direction of movement. As you can see, this is the result, and then finally I'm going to connect the vertices to each other. I'm going to create some new surfaces out of the copied or moved vertices. So to do this, in surface tab in freeform, check it out. Here we got a command or tool which is force point surface. It enables you to create a surface connecting 3 or 4 corner points. Then we had the corresponding command which was surface pointer Rhino. Check it out. So I select this tool and then the first point or the first corner, here it is. So I give the moved point, and about the second corner we give the origin object or the input object of move, and then for corner C we give the index 0 or 2 in list item. But in order to simplify the process of extracting the vertices, first of all I remove the wires and I delete the number slider. I zoom in list item outputs. Then I want to separate the outputs of list item. First of all, we have given the item 1 or the corner A, which were the moved one, then item 1 of list item, corner B and corner C. Watch this, this is the result. Like this way, I make a copy from this command, and then this time I give index 2 instead of index 0 to corner C. Watch this. So by this way we managed to complete the main parts of the project. And here I got a practice for you, is to move the back parts or the back vertices of the panels. I mean we should move them twice, and moving the moved vertices more. So guys, we're done with the first practice. But in the next step, we're going to control the movement of the corners by using the point tractors. First of all, we search for evaluate surface. Then we give the surface to create a point on the surface. Right click on the surface, reparameterize it. And when we reparameterize the surface, then we can specify the point on the surface in the domain of 0 to 1. Then we can use the MD slider, check it out, to control the point tractor on the surface. And then by using the command of closest point, check it out, we specify the cloud, and then for point, note that we should not use the triangle panels for these. But here we can use the list in dispatch. First of all, I add area. Here if we give the triangle panels the geometry of area, then we will have too many points, since previously we haven't selected the half of the triangles. So we give list B to geometry in order to extract the centroids, and then centroids to points. And then by using remap plus, we give the distance to data, and then defining the minimum and maximum values. Check it out by this way. And then we give the mapped value to factor of the movement. Watch this. Then let us check out the result. Here, as you can see, up to now we got no problem with the process, but as soon as I give the mapped values to factor, then we will have too many points on the vertices or on the segments, and too many surfaces are being created. But why it has happened? Here let us check out the list of geometry. As you can see, we got 55 branches and one item at each of the branches. In a way that here we got only one branch with 55 items in. Let us consider these here in geometry. For example, we got 55 branches, and in the second part we got only one branch or one list or basket with 55 items in. Then based on the behaviors of the connections, all of the items will be connected to the first branch and others and so on. Here the number of the branches should be equalized. So we right click and then click on graphed. As you can see, the data inside this parameter is graphed. So in both we got 55 branches that are independent to each other. And then by moving the MD slider or point on the surface or point tractor, it enables us to control the movement of the panels. And in order to display the results better, I hide the preview of these, and then I wanna assign a parameter, a color, or to assign the materials by using the custom preview for list A and B of dispatch. Check it out, and then we can display them in different kinds of colors, so we can have them distinguished in the environment or scene. For the two new surfaces be wrap join. Then we give the surfaces to join the surfaces with each other. Turn this off, and then the geometry to custom preview, and then blue for the color. Check it out. And then as we move the point tractor, the panels which are far from the point tractor have been moved in 1.25, while others are moved in 0.14. And we can flip them if you want to assign the higher value the panels which are close to the point tractor. This time I want to use the graph mapper, and then the graph types like sign. Check it out. And also by using another remap number or remap plus. Then for the minimum and maximum values 0.5 and 1.25. Check it out. And in order to display the results, I'm gonna increase the number of U and V divisions, or increasing the number of the panels 30 at both directions, like this way. Watch this sine wave, and this is the result. Then let us consider two techniques. The first one, I'm gonna tell you how to export these results as a photo or image. I mean, you've seen the images of the commands or these tools for many times. I mean, the images of the components and the parameters in many websites, but you did not know how to export them as image. But note that we do not use screenshot or stuff like that. Here in Grasshopper, we can export quick image. Check it out. For example, export high res image. We can export the current document as a high resolution image. We click on it, then an image file. We can specify the file path and also the name of the file, and also the file format or file type, PNG, and then the name of the file like Facade 01 or 01, and then the background color we can specify here in canvas background. Here, as you can see, we can have it in transparent, or in other words, by the slider you can control the transparency, for example like this. And then in zoom, the higher value provides us with higher resolution actually, so it increases the size of the file too, so it would take a long time for exporting the image. So we click on OK, and then this would be shown, and then we will have the exported file saved in the specified file path. And the next point that you may find it practical is to prepare a preview from the project in Grasshopper for ourselves. So to do this, bake the panels in Rhino. So we select them by custom preview, right click, bake, check it out. And then after baking the objects in Rhino, and then we can select these two and then bake them in Rhino. Following that, after adjusting the view or viewport, we can take a photo from the project. Ctrl A to select all, make 2D. We specify perspective for view and then view for projection, OK. Then we will have a 2D projection or 2D drawing from the specified view in perspective view. That, as you can see, it is projected on the construction plane, as you can see in the top view. Then I want to have this in Grasshopper. For example, I want to have the 2D drawings in the region. Firstly, we specify the frame or the region that we want to have the 2D drawing inside, and then OK, like this. Then we select the curve, right click, then we click on Center Rhino. then we will have the drawings in Rhino, as you can see. Then I place the projected 2D drawings in the region, and then I scale it at the size of the region. Then back to Grasshopper, right click and then load from Rhino. Then we select the 2D drawings and then have them in Grasshopper. Check it out, let me maximize the window. Then we can select the panels, right click, color, check it out. Then in attributes, we can control the thicknesses. And then by this way, we can have the preview of the project in Grasshopper. And in the next practice, here we can add the grids in Vector tab, like a square grid. Check it out. We add it, as you can see in Rhino. Following that, we specify extents of X and Y axis 20 along X and 10 along Y. By this way to create the cells. Following that, we want to scale the cells from left to right based on their sizes from small to big. So first of all, we search for area to extract the centroids of the cells, right click, and then we flatten the list by this way. Let me select them. And then by using scale command, we give the cells the geometry and then the centroids to centers. For the scale factor, can turn off the area. For example, we can specify 0.1 the items which are placed in the left side, 0.9 for the right side. So to do this, we can deconstruct the points to deconstruct the point into its component parts by this way. First of all, we give the centroids, which are 200 points, to the deconstruct point, and then we will have the X, Y, and Z component parts. And then I put the X component in a separate panel. Check it out, the X component for the first row. As you can see, we got the values. So up to now, we have extracted the X, Y, and Z components, and then by remap, I want to use remap plus. Then we give the data, following that minimum and maximum between 0.15 and 0.85 for the maximum value, and then we give it to the scale factor. Check it out, the cells are scaled based on their X component and also based on Y component. Watch this. This is the result. We'll turn them off. We select these and then create a group. And then I'm gonna use this example through another practices, especially on a surface. We add the surface parameter, then we create the surface in Rhino to set it in Grasshopper. Check it out. I extruded the curve and then I set it in Grasshopper. Well done. We internalize it and then we delete the surface in Rhino. Following that, I'm gonna use the panels in LunchBox. For example, the diamond panels. Check it out. To create diamond panels on the surface. Then for the U and V divisions, we make 2 number sliders, 20 for each, like this way. As you can see, as I move forward and as I progress the practice, I hide the geometries of the previous step or commands, and then by using area, we calculate the centroids. Following that, again deconstruct them, but this time I want to work on Z components. For example, remap plus, we give the data. Following that, we should specify the minimum and maximum values to create the domain or range, 0.50, 0.92, and then for the panels here in LunchBox tab, actually, scale, or we can use the panel frame to create an offset frame using a panel. You can find it in generate. We give the panels and then we give the scale factor for the panel frame for offsetting the diamonds. Check it out. We have turned off the other geometries and then custom preview. That enables us to make the panels distinguished. Let us specify a different color with color swatch. Watch this, blue. Well done in material. And we keep the color of the surface. Great. And we can flip the positions of minimum and maximum. Watch this. And we can easily use this technique in facades or designing the views of the buildings. We create a group out of these commands. And we turn off the preview for now. But about the next practice, we're gonna use a command, a new command actually. Meanwhile, we're gonna use the vertical rectangle. Then you will see that again we're gonna operate the pointer tractor. We rebuild the rectangle and then we show the control points. After increasing them, we select them, move them by this way. We moved some of them forward and others backward, like this way. You know, this is our surface for this practice or example. Then we search for network surface to create a surface from curve networks. And then set multiple curves. We should specify the U curves and the V curves and also the continuity. Watch this. And also here we can control the continuity or modify the continuity of the curves of the surface actually, and have a different surface. Then I'm gonna have some boxes on the surface, and I want the boxes to be moved on the surface forward and backward based on the pointer tractor, or maybe randomly. To do this, here we got a surface box to create a twisted box on the surface patch, and we give the surface, and then in domain we should specify the number of the divisions actually. But how? By using the divide domain to divide a two-dimensional domain into equal segments. We give the surface to domain. Since we're going to create some boxes on the surface, we give the surface to domain and then the segments to domain. And then we should specify the U and V counts for divide domain 2. Check it out. This is the result. Here we got boxes on the surface at the specified value in U and V count because of using surface box. And then here by using random, we should specify the number based on the number of the segments. First of all, we search for list length. We give the segment to list, and then let's check out the list length. And we should give it to number of the random because of the number of the items. And then by using construct domain, watch this. Construct domain to range and then domain start and end between 1.2 and, for example, 2.5. Later we can change it, no matter. And then we give the random to height of the surface boxes. So we can control the height of the boxes randomly or even by the point tractor. And finally, by using the custom preview, we can assign the materials to the boxes and display them with different kinds of colors. Let me bake them in Rhino. Watch the results. And then in the perspective view at the rendered viewport in Rhino, watch this, we can display them by this way. And let me delete them in Rhino. But before deleting them, let me extract the curves or 2D drawings. Since we need them here, we're gonna use the command, the new command in another practice. For now, for example, for transferring or moving the objects on the surfaces. We got different kinds of methods and approaches for transferring or moving the objects on the surfaces. That I introduced Surface Box as one of the approaches. But how, for example, here I draw a sphere like this way, and then I wanna place or move the sphere on the surface. Then at the first step, we wrap, we set the surface to import it to Grasshopper, and then by using and typing BB bounding box to solve oriented geometry bounding box, and then check it out, we have created the bounding box which is surrounding the sphere like this way. And then, in the continuation, I want to place the sphere in the boxes which are on the surface. In other words, we're gonna make some spheres and put them into the boxes. To do this, box morph an object into a twisted box. Then we give the geometry, which is the sphere, to the geometry of box morph, and then the reference, which is the bounding box, and then the target is the twisted boxes which are placed on the surface. And then we will have such a result. Watch this. By this way, we connect it to custom preview, then we can display the results distinguished like this way. Well done. So guys, one of the approaches that we can place the patterns or the panels or the objects on the surface is using surface box, bounding box, and morph box, or box morph actually. So guys, try to put these nodes into your minds that we have used divide domain 2 for the surface, and then we have given the segments to surface box. Select these, disabled, but I internalize the brep and make a group out of these. Internalize data. So after internalizing them, we will have no problem if we had the items deleted in some cases, since we can use them in Grasshopper. And let us consider another example about this part, and then we're gonna finish the session of 4 or episode 4. This time, suppose that if I want to draw 3 circles in Grasshopper, just like this, check it out, and then if I want to place some curves on this circles, let us move the process forward in Grasshopper by using circle tool and also construct point XYZ. Check it out. Firstly, and gem pool for creating multiple values. Here in gem list editor, we need 3 values and then the minimum and maximum between 0 and 30. We give the planes and then we give the X or Z coordinates. Check it out. We have made the points along Z axis. Following that, we're gonna consider 3 numbers for the radius, since we need 3 circles by the gene pool. Watch this, like this way. So guys, we're done with the 3 circles by Grasshopper, 3 variable circles, or 3 circles with variable radii. And then by using divide curve, we want to divide the circles or curves. As you can see, we got a group which is consists of 3 circles. Here we right click and then we graph the list or data in the parameter. After graphing them, we will have the 3 branches and 1 circle at each of the branches. I mean, each of the circles are independent to each other and they are separated. I specify the number of the count or division, for example 16. So the division is equal among the 3 circles, and then by using the param viewer, we're gonna check out the points, 3 branches and 16 points at each of the branches or on each of the circles. Here by using interpolate curve, watch this, we want to connect these points to each other, and you will see that we will have the circles or the curves same as the circles. If we hide the previous circles, check it out, these are the results. This time here we got 3 branches with 16 items, but I want 16 branches and 3 items at each of the branches. So we need to flip the items or data by flip matrix. We give them to vertices. Watch this, this is the result after swapping the rows and columns. Finally, we can change the number of these items, that we can use shift list to reach to our goals, or otherwise we can rotate the circles. I mean, before dividing the circles, we can rotate them. We open some space, we search for rotate to rotate the circles in the plane. We give these circles to the geometry of rotate, and then area, and I give the centroid to the plane, and then the rotation angle. We right click and then we set it per degrees, and then we add one more gene pool, 0 to 120 degrees by this way, and then we give it to angle. But here, as you can see, we got 3 variable values that we want to give them to angle. We got 3 items in only 1 branch, but there we got 3 branches. We may have some problems. Let's check it out. Watch this. Here we got 9 items. In a way that we got only 3 circles. To do this, I right click and rotate, and then I graph the list, check it out, and then we give it to curves. I mean, after rotating the circles, we give them to divide curve. Well done. And then we can control the rotation angle for each of the circles like this way, by moving the sliders in gene pool. And nextly we can set 0 for first and the third one, and then for the second circle we can assign, for example, 23 or 24 and stuff like that. And then here, by using mirror, check it out, we mirror the rotated curves like this way. Watch this. Following that, by using the 3 circles here and also loft to make the surface, right click, flatten the list. Watch this. So we have created the surface, we move the loft here, and then we can use this curve to split the surface. So we can use surface split. Watch this. We search for it in the search box, and then we add it into the canvas. Then we give the surface to the surface split, and then the curves or the split curves. Since here we got too many curves, we have to right click and then flatten the list, and then giving the curves. This is the result. Following that, we can turn the preview of these and then baking the results. And as you can see, we have split the surface into some separated parts like this way. We're going to talk about the command of mirror combine item. So just as usual, we're gonna start with an example. In fact, I'm going to give you a brief explanation about mirror combine items that mirror a set of list items across it, and or start and combine it with the original set. And then to give you an example, I add the panel as you can see on the screen. Following that, I want to define some numbers or values to consider them as the data. For example, 1 2 3 4 5 like this, and 6 and 7. And then we right click on the panel to click on multi-line data, and then I give these numbers or values in the panel for the input of mirror combine items like this way. We give the list. Following that, let's check out the mirrored list, and here as you can see, our list is mirrored in the panel of output. And as you can see, the list is start from 7 to 1 like this way. However, there are two more outputs, F and J. By F we can flip the mirror. If you set it to true, check it out, it flips the order of the mirror of the items. And as you can see, the items are start from 7, but if we set it to false, it is start from 1 and then from 7 to 1. And the next one is join. If we set join to true by the boolean, here as you can see, 7 is common between the two mirrored lists. Previously we had two indexes with number 7, but right now we got only one index with number 7, since we had number 7 in the original list and also in the mirrored list. So according to this, here a split index, only if join is false, as you can see it is 7. And in the continuation, I'm gonna exemplify some other cases, and the value which is displayed in a split index shows the length of the list. It shows that we have 7 items. So here in Rhino, by using interpolate curve, I draw such a curve. Following that, we move the control points like this. We move them along X, Y, and Z axis to have a non-planar curve. Following that, we set the curve in Grasshopper. Then in the continuation, we're going to place an cross section on the curve. We hide the curve following that by using the component of perpendicular frame in order to create some numbers of frames on the curve or along the curve. Following that, we can have the circles on each of the frames along the curve. We click on pair up frames, we give curve to C or curve, and then we give the frame to the circle or the plane and 24 for number. And then we specify the radius of the circle in order to display them better, like 2.5 as you can see in the scene. Then in the continuation, we want to assign variable values for the radius of the circle by using range, and also construct domain to specify variable values for the radius. Here for the construct domain, we make copies from the number slider, and then we specify domain start and end 1.8 to 6.8. Check it out, this is the result. The minimum value 1.8 and the maximum value is 6.8. And then the length of the list should be equal with the number of the frames. Then as we are going to mirror them later, we should assign half of the number of the frames, since after mirroring them, the number of the frames will be multiplied in 2. So I give an even number and we divide it into 2. For example, if we divide 24 to 2, the result would be 12. And as we are using range, as you can see, we got 13 numbers or indexes. And then here when we set join to true, for example, when we give 6 numbers or 6 indexes, then it also considers the repetitive number, which is 6. And right now we got 13 numbers, we got 12 indexes and 13 items. But when we set join to yes, then it will remove the repetitive item or the maximum value, which was 6. Right now let us give it a try and explain again. Here we have made some numbers between 1.8 and 6.8 that the number of the values are half of the number of the frames. So right now we need 25 numbers or values. Right now we got 13 numbers or values. If we multiply 13 into 2, the result would be 26, and then we should split the index, so then we will have 25 numbers. We use mirror combine items. We give 1 to join and also the input, and when we define 1 for join, it means true. And here, as you can see, the values are started from 1.8 to 6.8. Check it out. As I told you before, it mirrors a set of list items across its end or start and combine it with the original set. And as you can see, the mirrored items are combined with the original sets. And then we can have the surface by using loft. Check it out by this way. So guys, we're done with the first part of this example. And we hide the loft and we make a copy from the curve and the prep frames, and let us hide them by this way. Then for the next example, this time I want to use rectangles instead of the circles. First of all, let us draw a rectangle here in the top view. I want to show you how to specify the dimensions of the rectangle. For example, for x and y coordinates or axes, we can define the domain -2 to 2. Here, by using construct domain, we can consider a domain for specifying it as the length of the rectangle, like -5 to 5. Check it out like this way, and also the same domain for the width of the rectangle. Check it out for both x and y directions or axes. And then we have the rectangle at the specified length for the segments. And then if we use negative for each of these segments, then we can have the rectangle scaled equally at both sides. Check it out, we can use negative. And then even by moving these 2 number slider instead of controlling 4 number slider, and then scaling the rectangle. Following that, we're going to orient these rectangles on the frame or along the curve. Then I should connect the frame to the planes. Check it out. And as you're concerned, we can change the dimensions of x and y. Then just like the previous example with the circles, that we have assigned variable values to the radius as a result of combining the mirrored list with the original set of lists. So the sizes of the rectangles won't be equal to each other. And as I told you before, here we should make a number of values or a set of values and then use mirror combine item. For example, if we had 24 or 25 indexes or items in the list, and then this time we're going to make some other values. For example, we can divide them into 2 because of mirror. And to do this, let me search for the range by this way. And to do this, after adding the range, following that division, I give division 24 to division. I divide it into 2. We give the same number of the prep frames to A or division, and then we want to modify the domain. Use construct domain, and then I define the minimum and maximum values. For example, for the minimum, -6 to 6 by this way, and then I make a copy from range, and then I set the decimal precision to 2 decimal places, and one more copy since we got X and Y. Since we need 2 separated ranges for X and Y, and then we can associate it to the construct domain and then give them to X and Y. We make a copy from this, and then I set the value, I specify 6 instead of -6. Check it out, I give it to X. Following that, I want to revert the values. As you can see, we got 2 number sliders, and also I have used negative for reverting these values. For example, we got -6. We give 6 to construct domain, and then to the another one we got the negative values. Check it out, and other is the positive values. Let us check out the values. Then I want to search for construct domain to create a range or domain by these numbers. We give the inputs panel -6 to 6, -5.6 to 5.6, and so on. Following that, after constructing these domains by construct domain, and as you can see the output in the panel, and I want to consider them as the inputs of X and Y of the rectangle. First of all, let me select these and hide their previews, and then I associate these ranges or domains to X and Y. Right now we have considered them as the segments of the rectangle. Check out the result. And as you can see right now, the numbers are combined, or a combination of positive and negative values which are reverted. But previously we wanted to use mirror combine item to mirror the items in the list and combine the items which are mirrored with the original set. So here, before using the construct domain, we should mirror the numbers or items in the list by mirror combine items. We give the range to mirror it, and then we give it to construct domain. For both lists I made a copy. Check it out, this is what we expected. Then in the continuation, let us move these number sliders to change the domain start, and the values. I want to have the list number at the start of the domain, and the high numbers at the middle of the domain, and the less ones at the end of the domain. Then, for example, I can minimize the domain start, and then the value, like for, we increase the value -1.72, and as we move these number sliders and modify them, we can meet our needs. But for now I think it is okay, so we keep it. Then in the continuation, we're going to convert the rectangles to some surfaces. Let us make a copy from the commands here. We should select the number sliders as well, and all of these, the curves, number sliders, and others. Ctrl+C, Ctrl+V to paste them by this way, and I hide the others and hide their previews, also these. Let us continue, and let me set the commands and parameters and components in order and align them and hide others. And after organizing these, we can continue. So these squares or the rectangles want to be converted to some surfaces by using loft. Check it out, loft, and this is the result of loft that we have made a surface. Then in the next part we want to twist the surface actually, or in other words we want to rotate each of the rectangles, since right now as you can see all of them are aligned with each other. So we want to twist them or rotate them in relation to the previous one. We can use rotate. So we give the geometry to rotate. Following that, we should specify the rotation axis. So we give the frame to the plane of rotation, and then for the angle, the right click to set it per degrees as usual, and then specifying the degrees or angle of rotation 24.3. As you can see, we are rotating them together equally, while I want to rotate them individually. I mean, the assigned angles to each of the rectangles should be different. So again, we should create a range, for example from 0 to 190, and then we can use mirror combine item to mirror the range, and then we give it to the angle of rotation. Let us check it out by using construct domain, for example between 0 to 90, like this way, for the minimum and maximum values of construct domain. Then in this domain of range, we want to create a range. We add the range component, we give the domain to the range, and then we should specify the number of the values that we want to specify them. We can remove the division here, and using 12, which is the result of the division, and then I give it to the number of range. We give it to the panel. Watch the domain of range from 0 to 90. Then in the continuation, I'm gonna use mirror combine item to revert these values or mirror them. We search for mirror combine item. We give the list of values, and then for join, we invert it to remove the middle number. Then we give the value to the rotation angle, and as you can see, let me increase the value. Following that, we loft these rectangles to have the surface twisted or rotated. Then we search for custom preview to assign a color by this way. Then we can increase the twist value. Watch this. So we managed to twist the surface. So let us continue, guys, after creating and twisting the surface. But to add more details to the practice or project, we can, here as you know, we got 4 surfaces which are rotated. Here we can select each of them and create some patterns on each of them. We can use the construct brep. We give the loft to the brep. Following that, I'm gonna create some panels out of the faces of the construct brep. So I search for the quad panels. Here it is. Then we give the faces to the surface of quad panels, and then for U and V directions we can consider 2 values. 46. We should minimize one of them, for example setting 2 or 3. Check this out. We should minimize the V direction and increasing U direction. For example 8 for V and 40 or 60 or 80 for U direction, like this way. Well done. After doing this, we can minimize the V direction 6 or 4. Then in the continuation, it's time to use the panel frames tool that you're already familiar with. It we can find it in LunchBox to convert these faces or panels to some frames at the specified scale factors. We flatten the panels and then in a scale factor like 0.2 to 0.9, and then we increase the scale factor, watch this, to narrow the frames. It is okay. Then we give the frames to the custom preview, and then we assign the color to show them distinguished in the scene. And maybe you wanted to assign a different color to the panels, so I make a copy from the custom preview. We give the panels, then we specify the color or material like blue. Check it out. However, we could have used color swatch. Then we had access to all of the colors. Check it out. Let me search for color swatch for displaying the panels. Like this, I gave it to material. By this way, I think white is okay. Then let us consider the other tasks that we can have done upon these. For example, the geometry here can be modified by the polar array for arraying the objects polarly. Let us give the code panels to the geometry. We hide others. Check it out. This is the result. And after arraying the objects, and then I turn on the custom preview, and here I move backward. Here in loft we can do something else. We select these and I group them. This time I wanna convert these to some ribbons or strings. But how? Actually, to do this, I wanna use the component of isotrim, and actually to be able to use isotrim component, we should have the surfaces instead of the polysurfaces. So we add the isotrim, and then by using deconstruct wrap, we convert the loft to 4 surfaces. We can hide these, select and hide the preview, Control Q, and then for the domain of isotrim, we can use divide domain 2. We search for it to divide a 2-dimensional domain into equal segments, and then we can give the surface to the base domain, as you can see, or I input. Check it out. I give these faces to the base, and let me check the items by using prompt viewer. Data with 4 branches and 100 items at each of the branches, and I should graph the faces to have 4 branches instead of 1. And then for U and V directions or counts, we can specify 1 for U count and 8 for V count, like this way. Following that, I wanna remove some of them at the specified pattern. We can use dispatch. We give the list to dispatch, and then we separate it to 2 lists. We can use custom preview to show you the 2 separated lists, like list in A and B. Check it out, like this. These are the ribbons. And other tasks that we can do is to show the 2 lists of A and B different to each other by using the custom previews and specifying various colors in color swatch, or even creating some new panels. So what should we do if we want to have the panels? Here we can start with minimizing the divisions. Right now we have divided each of the faces to 8 ribbons. Since I have specified 8 in divide domain 2, so right now in order to create the panels, we can minimize the number of the divisions, U and V, for example 2, and then we can make a copy from quad panels and then give the list of A of dispatch to surface, and after creating the panels we can show them with the custom preview distinguished, and even we can consider the panel frames. We give the panels to the panel frames and then to the custom preview, and then we hide the panels and then we consider the frames. Then we can modify the scale factors or the divisions of, for example, I make a copy from these. I minimize the number of the division of the panels. For example, I set it to 2. This time is better. And as you are concerned, scale factor enables us to modify the amount of opening of each of these panels. Check it out. At this episode, we're gonna deal with the applications of the command of twin curve within an example together. So at the start or at the beginning, we have sketched a curve like this by using interpolate curve, and Rhino, I make a copy from it, then I rotate it like this way, as you can see. Then I start the command of twin curve, and then I draw these curves between the two specified curves, and then in the command lines I click on number to specify the number of the curves between the two original inputs. For example 5, like this way. The record history has been recording the modifications. Then I can move the control points, so whatever changes we make on the origin inputs or input objects will be applied on other outputs, as you can see on the screen. We're gonna do the same thing in Grasshopper right now. So let's check it out. Right now we get back to Grasshopper. So firstly we add a circle parameter. Since I'm gonna create 2 circles, I specify the radius 12.5. And for the second one, I make a copy from the number slider. Then I specify the radius like 9.8. Following that, I want to specify the position of the circle, for example, in XY plane. And then for the second circle, we can specify XZ or YZ. For the plane, check this out. I hold down shift while I'm making the wires, since I need both of the circles in 2 different planes. Following that, I need to modify the origin point of XZ plane. We add a point, and then we right click on it, set from point, and then we import or type 00 enter. Then we select the point, and then we move the plane by using gumball for adjusting the position of the plane or the circle. Right now we got 2 planes and 2 circles on each. Following that, it's time to search for list item command or component. We give the circle to the list item. Then we want to extract index 0 and 1, or the circle, the first and the second circle. Then by using twin curve, we gave A and B. Then this is the result, as you can see. Then for F, we can specify the factor between 0 and 1. 0 is matched with the first one and 1 is matched with the second circle. We can set 0.55 or 0.5 if you want to have a curve between them. But if you want multiple curves, you should need range. We set the domain 0 to 1. So we can consider the number for the range, and then we give it to F or factor like this way. Then you can control them by the steps. Let me remove the wire of range. Then I want to rotate the second circle or the XZ circle. I don't want it perpendicular. We can use rotate. We give the second circle and then we rotate it. Let me specify the plane along XZ plane. Watch this. Because the default plane was XY, I should set the angle per degrees, and Check it out, we are rotating this circle based on the plane that it is not my need. So to do this, I should use XZ plane, and then we can rotate it according to the specified origin point. So I consider another point for the XZ plane, then I turn off the preview of others, then we can rotate it. Check it out. This is what we expected. And then instead of the input of twin curve, we can use the rotated circle instead of the previous one. Well done. Following that, we give the index 0 to the curve by this way. Watch this. We got the middle curve between the two circles as well. I modify the position of the curve by the gumball, and then we change the rotation angle. Then I'm gonna use the range for twin curve for making the curves of twin curve. As you can see, here we got some curves or circles that we can convert them to a surface. We can hide the preview of other objects, and then we give the list of curves to the left. As you can see, we got the surface actually. Then I wanna assign a wave like to the surface, So we're gonna use this patch in order to divide the curves in the specified pattern. We search for this patch and then in pattern. Then we should modify the default pattern. As you can see, it's true false. Right click, we delete them. Then in set multiple boolean, then I define true false, false. Then it selects 2 and deselects 2 curves. Following that, I give it to the curve to show you the result of A. As you can see, some of them are selected and some of them are not. And you can find the deselected items in B output. And then I want to use offset curve. For example, I give B to curve of offset curve. Check it out to offset them. For example, the default value is 1. I set 1.23, then you can control it, the offset distance Then I'm gonna create a list out of the curves of list A and out of the offset curves. Then we can use loft to create our new surfaces. So to do this, let me minimize the offset distance. Following that, we can use weave, and then for the stream of 0, I'm just defining the pattern 1100. Don't forget to click on multi-line data and then defining the pattern in the panel. Following that, we give the strings to weave. Following that, we should specify the pattern. I flatten the offset curve, and then we can check out the weave in point list and also point on curve. I give the weave to point on curve like this way, just to check out the number of each of these curves, and we increase the sizes of the numbers to check them out. Watch this, the order is correct, 0 to 14, great. The two lists were combined. Then by using loft, we can have the surface as you can see. Watch this. We select the first point, the primary point, and we move it. Then we can modify the rotation angle or the radius of the circle or the offset distance, or even modifying the pattern of dispatch or others to control the geometry. And after doing this, we're gonna move the process forward. For example, I'm gonna use another curve instead of the circle. For example, I wanna use a deformable circle instead of a planar circle. We make a copy paste. we hide them, and this time I wanna draw two circles in Rhino instead of using the curves of Grasshopper. Deformable circle, check it out, and we select the firstly, let me make a copy. Following that, we move the control points to deform the circle. Right now, I'm just selecting them, and then I move the control points to deform the circle. Then I want to connect these two circles to each other. Then by curve, we set them into Grasshopper to import them into Grasshopper actually. Then these circles, the new circles, are going to be replaced with the previous ones. I gave them to list item. And then let me see. We can delete the rotate. I mean, we give the circles directly to the left, and also offset, since as you can see the offset is not applied. As you can see, we got the twin curves, but they are not offset. Let me show you, watch this. As you can see, the left is okay here, and dispatch and creating two lists. Here the point here is that the offset curve requires planar curves. As you can see, offset plane must be provided if the curve is not planar itself. This is the error message. And as here we are using deformable circles, you are encountered with this error message. So what should we do here? Here we can use offset curve loose for the non-planar circles or curves. So we use this instead of offset curve. Check it out, we have replaced it with the previous one. And watch the result, everything is okay. We have solved the problem. We can hide the others and have the surface by this way. Then we can edit them and move the control points, Ctrl Z to undo them. And for instance, we can, let me at first delete these. We can project the bottom curve or circle on the construction plane. We increase the number of the curves which have been made by twin curve, and we rotate the top curve and move it like this way. And index 0 or the bottom curve, I give it to the geometry of project. As you can see, it is projected on the construction plane. I love them, as you can see, and then by using quad panel, that you can find it in LunchBox to make some panels out of the surface. But before that, I want to scale the bottom curve from the center of the circle as the scale factor, not 0.75. Watch the result. The bottom curve, index 0. And this is the result. Following that, as I told you before, we're going to create some panels by quad panels that you can find it in LunchBox tab to specify the U and V divisions for number of the panels. For example, along U direction 4 and 30 along V direction. By this way, even we can minimize V. Following that, by using panel frames, we give the panels, and then we will have the frames. Then in scale factor, we can control the value. Let me control the value of V, 30 for example, and then custom preview, only assigning the material to the frames. And then the panel frame, we want to modify the scale factor like 2 digits, and we increase the value, not 0.9, like this way. Then we hide this and make such a panel. And then for the assigned color to the panels, we search for color swatch, then we specify the color like the gray. Check this out. By this way, this is the specified color, and then we want to continue. I make a copy from this and I scale it to mirror the circle. Following that, I want to create another surface between two curves. Ctrl C, Ctrl V to make a copy out of these. However, I should deselect these commands or components since we do not need them. Like this, we make a copy. Some of them should be moved upward, like project and area for the centroids. So right click, set multiple curve, the two mirrored curves. As you can see, then I want to create a bridge. Let me move the curve. Watch this. And then we can change the range. We can minimize it, for example, as I showed you. And I make a copy from the bottom curve and changing the continuity like this way. And then from these parts, since we need the frames as well, we draw the window, make a copy, Ctrl C, Ctrl V, then set multiple curves by this way. And while I was rotating the curve, I have ruined the geometry that I can rotate the bottom curve to revise it or fix it. Because, since I have mirrored the objects, some problems just showed up with the geometry. Wait for a second. Well done. And the other tasks that we can have them applied on the geometry or object. Let me modify these by this way. I set the custom previews and also the lofts next to each other like this way. I align them to bake them in Rhino. All of these baked. Then we can display them at the rendered viewport in Rhino and check them out. So guys, as I explained before, we just dealt with the twin curve command within the example. However, you can go through other tasks and practices like creating some panels on each of these surfaces or lofts, or creating the ribbons by using isotrim as I told you before, in order to delve into more professional tasks and take your skills